Hello, my name is John Bannon. I'm an attorney and philosopher. In this video, I'm going to explain what a Hanssonian superdeterministic block universe is. When I speak of Hanssonian superdeterminism, I am referring to a very specific version and unique version of superdeterminism based on a proof by Swedish theoretical physicist Dr. Johan Hansen that was published in 2020. You can find his proof in the peer-reviewed physics journal, Physics Essays, Volume 33, Number 2, June of 2020, pages 216 to 218. It's entitled Bell's Theorem and Its Tests, Proof that Nature is Superdeterministic, Not Random. Hanssonian superdeterminism is very different than classic superdeterminism. Classic superdeterminism, which was first posited by Dr. John Bell in 1985, uses hidden causal variables to explain the apparent spooky action at a distance in the correlations observed in entangled particles. Hanssonian superdeterminism disproves physical causation, or cause and effect in physics, or probabilistic causation, which means it can't rely on hidden causal variables. Instead, it relies on a static, unmovable, unchangeable, permanent pattern of particle positions through the dimension of time. So, the Hanssonian superdeterministic universe is just like an Einsteinian block universe. So it's got 3 dimensions of space and 1 dimension of time. Now, this dimension of time is static and it's also hidden. You can't see it. And what it's saying is that all events, both past, present, and future, are all equally real and all presently existing in this 4th dimensional static block universe. So you can draw a representation of a block universe like this. So we start with the Big Bang, and this is the arrow of time going away from the Big Bang. And this is the expanding universe as we go along the static dimension of time until, let's say, the present moment. So inside the static block universe, this 4D reality, it consists of particles. So you can imagine slices of this 4D block, which would be your 3 dimensions of space. And in each of those slices are particles. So all there is in the 4D block is particles and nothing. So let's imagine a 3D slice of this 4th dimensional object. So you can imagine that your present moment is located here on the static dimension of time. And what exists on that slice or hyperplane of space-time is particles. And these particles are permanent, unmovable, unchangeable. That's because there's no cause and effect in physics. So nothing can be caused to move in time. So there's no moving time. There's a static dimension of time, but there's no moving time, as in like a flowing river. That sort of moving time. And nothing can be changed because nothing can be changed if it can't be caused to change. However, the appearance of these particles do change through the static dimension of time as they appear on different hyperplanes of space-time, even though the particles themselves are fixed, like pebbles in concrete on that particular slice. These same particles well, slightly different aspects of these same particles through the particle's world line appear on abutting hyperplanes of spacetime or intersecting hyperplanes of spacetime. So a particle is, let's just say, a point in 3D space, and then the next abutting hyperplane of spacetime will have a representation, quite possibly in a very similar location as the first particle. And this creates a fourth dimensional world line, or some call it a space-time worm. So particles are actually fourth dimensional objects, but with imagine a fourth dimensional tube, like this line here. And if you slice a fourth dimensional tube, what you get is a three-dimensional sphere in frozen three-dimensional time. You can roughly think of that as a particle. So Hanssonian superdeterminism is talking about a higher dimension, this hidden dimension of time. And the reason that Hansen can prove that this hidden dimension of time exists is because he can prove cause and effect in physics is not real. And because cause and effect in physics is not real, then the present cannot cause the next moment in time or the future. It's impossible. But we know the future arrives nonetheless, which means that the future must already exist somewhere. But because it doesn't exist in the present moment, then it has to exist in a hidden static dimension of time, because it has to exist somewhere, because the present doesn't cause it to exist. It doesn't create it. There's no transformation that's going on in the static block universe. You can't have transformation of energy or matter or mass without causation or without moving time. So it's not a process of transformation that's going on or a process of moving time. Rather, it's one fourth dimensional static block universe with particles that don't move. That's what's really going on. The the uh, the conscious experience we have of motion is an illusion because nothing moves in the Hanssonian superdeterministic universe, which means our experience of motion has to be an illusion because there is no motion in the universe. Now, um, so if you imagine a frozen moment of 3D space, and then you stack those frozen moments against each other in an abutting sequential line along a hidden static uh, dimension of time. And that's what causes the motion that we observe. Then you can understand how a fourth dimensional object can produce this illusion of motion. Essentially, uh, our illusion of motion can be analogized to a fourth dimensional flip book. So if you take a flip book and there's drawings on the pages of the flip book, and you go through the different pages quickly, it looks like the drawing's moving. But it's not really moving, it's static drawings. It's just because you're flipping through the different pages that it looks like it's moving. So the Hanssonian superdeterministic universe is kind of like that. It's like a flip book, a cosmic flip book, but it doesn't have pages that need to be turned. Rather, the changes that occur among the hyperplanes that result in this appearance of motion is due to the static dimension of time. So essentially, it's the static dimension of time that gives the illusion of motion through these different hyperplanes of space-time. It doesn't require somebody to flip the pages actually. Um, so the Hanssonian static block universe is comprised of particles through the static dimension of time. And the past, the present, and future are all equally real. So all the events that ever occur in your life from beginning to end, birth to death, are all equally real. They're all present in the block universe. They're permanent, they're not going anywhere. And the reason you don't experience your own past or your own future at the present moment is because you're in the present location for you in the dimension of time. So your past is over here, your future is over here. You're here right now, which means you can't experience those things. That doesn't mean your past and your future aren't real and aren't in the block universe. You're just not located in that position within the dimension of time so that you presently experience them. So in the block universe, there's no moving time. Nothing can move. Everything is static. Nothing changes, and everything is permanent. So the particles that appear on the hyperplanes of space-time through the static dimension of time, they create patterns. And these patterns we describe with our logical mathematical laws of physics. So particles and nothing else exists in a Hanssonian superdeterministic universe. So particles or events, they're the same thing, are fixed coordinates in the 4D block. Um, However, in a Hanssonian superdeterministic universe, there's also superdeterministic correlations. So you've heard the old saying that causation is not correlation. And that holds true in the block universe. There's no such thing as causation. All there is correlations. That's it. So particles in one part of the block universe are correlated with other particles in the block universe, whether those particles exist in the past, present, or future. So you could have a past particle that's correlated with a future particle because they're statically positioned in the dimension of time. They're not causing each other to be correlated. They simply are correlated statically speaking. Now, the simple example of a correlation is used by Dr. Hanson in his proof. That is the opposite spin correlations seen in entangled particles. So you could take two entangled particles, separate them some arbitrary distance apart, measure them at different times, and you will get the same opposite correlated results. If one is spin up, the other spin down. If one is spin down, the other spin up. Those are correlations. And those correlations exist through the static dimension of time. So one, you could be measuring one entangled particle here, and then the partner particle over here, and there's still this correlation. However, the correlations are much more extensive in the static block universe than simply entangled particles. Because every event is fixed, then all the other events, past, present, and future, that relate to that event are correlated based on that one event. So you can determine the values of any of these correlated events based on the other correlated events, whether in the past, present, or future, in which they are correlated. So, for example, um, imagine a light beam or a laser beam emitted and at the moment emitted at the moment of the decay of a radioactive atom, and then that light beam hits a sensor, and that sensor sets off a marathon race in New York City. So you just imagine that setup. So you have a radioactive atom, it decays, it sets off a detector, the detector sets off a laser, the laser shoots at a sensor, the sensor sets off a dinging noise and begins a race, a marathon race in New York City. Because of superdeterministic correlations, all of these events all exist at the same time in the block universe in different locations of the static dimension of time and space-time. But they're all correlated in the sense that you can determine any of these correlated events or values based on the other events in which they're correlated. So if all you knew was that the time that the race started, you could figure out or determine all these other events. Because if the race started at some certain, some time, then you know when the ding had to happen. And if you know when the ding had to happen, then you know when the laser beam had to hit the sensor. And if you know when the laser beam had to hit the sensor, based on the speed of light, then you know when the light must have left the laser emitter. And if you know when the light left the laser emitter, then you know when the detector had to detect the decay of the radioactive atom. So all these events are correlated with one another. They're all um, existing at the same time in the static block universe. So they're all, they create this web of um, events, correlated superdeterministic events. And if you know one of the events, you can determine all the other events. So they're all determinable based on these superdeterministic correlations. So because you can determine uh, these one of these correlated events, you can determine the values of all the other correlated events. A big problem in physics is the inherent randomness of certain quantum events, like the timing of the emission of the decay of a photon from a radioactive atom. That seems to be inherently random. So it could be some random value. And when you look at the value itself, there's no way of knowing exactly when this atom is going to decay. This is an example of acausal physics. Except that in a Hanssonian superdeterministic universe, because all the events, whether past, present, and future in the block universe, are superdeterministically correlated with one another. If you knew the correlated events, then you could determine what the random value has to be. So uh, let's say this random event of this decay of this atom was 0.66 seconds. Ordinarily, a physicist would never be able to predict exactly when that atom would decay. But because these other events in the chain, it's not a causal chain, but in this stream of superdeterministically correlated events, can determine the moment of the decay, then if you knew these other events, then you could determine the exact value or the time at which this atom would decay. And therefore, it's not really random. It's a random number that must be a specific value based on the correlations of all the superdeterministic events. So, um, 0.66 seems random, but is it really random? Well, if you know the rest of the story that's predetermined and set in stone like pebbles in concrete, it can only be this value. So it's not there isn't some random chance that it's going to be this value, 0.66. There's a 100% chance this is what the value is going to be in a Hanssonian superdeterministic universe. So this essentially solves the measurement problem, solves the issue of the inherent randomness of quantum events. Lots of people would say, well, because there's these inherently random quantum events, the future must be open. because how can a future be predetermined if an event is inherently random? Well, the answer is because the future and its superdeterministic correlated events are what actually determine the random value. So it's not really random once you know all the correlated information. So um, up goes the Copenhagen interpretation in smoke. Instead, you have a Hanssonian superdeterministic interpretation of quantum mechanics that can just as easily explain the inherent randomness of quantum events. Okay, so I hope that helped in terms of understanding what Hanssonian superdeterminism is all about. You know, some people, because we experience what we think is cause and effect in our lives all the time, we assume that cause and effect in physics must be real. But it's actually an illusion, and it's caused by the changes in patterns across hyperplanes of spacetime that just so happen to be very similar, which gives us a sort of film strip or movie reel like uh, appearance in the static dimension of time, which we mistake for causation when it's not really that at all. Okay, well, I hope that explanation helped, and take care.